Good morning to all. Today our topic is on refrigeration and air conditioning. In this refrigeration and air conditioning, subtopic is the air conditioning. In this air conditioning, we discussed about the enthalpy of the moist air. The enthalpy of moist air is a total heat of moist air. Total heat of moist air is the sum of the sum of sensible heat of sensible heat of the dryer and sensible heat of dryer and latent heat of sensible heat of sensible heat of wet water vapor latent heat of water vapor. Enthalpy of moist air. The enthalpy means the total heat in the moist air. The total heat of moist air is a sum of sensible heat of the dry air and sensible heat of the water vapor, latent heat of water vapor. The moist air, it is a combination of dry air and water vapor. So the enthalpy of the moist air, it is the total heat of the moist air is a sum of sensible heat of the dry air and sensible heat of the water vapor, latent heat of the water vapor. So the H is equal to so the heat, the sum of the sensible heat and sum of the sensible heat of water vapor and latent heat. So that one is equal to, so H of dry air and H of water vapor. So here the H means this is the enthalpy of moist air in kilojoules. So HA means enthalpy of dry air, same. HV is the enthalpy of water vapor. So same kilojoules. Now the H, it is a enthalpy. So what is specific enthalpy? So the specific enthalpy so specific enthalpy, it is denoted by small h and it is in terms of kilojoule per kg of dry air, kilojoule per kg of dry air, kilojoule per kg of dry air. It is denoted by kilojoule per kg of dry air. So the small h is equal to h by mass of dry air, mass of dry air. So here the ma is equal to mass of dry air, mass of dry air. So the capital H is equal to h ma, like similarly HA is equal to enthalpy of specific enthalpy of dry air and mass of dry air, and enthalpy of water vapor is equal to specific enthalpy of water vapor and mass of water vapor, mass of water vapor, mass of water vapor. So now this is equation 1. Substitute in equation 1, in equation 1. So HMA is equal to HAMA plus HVMV, HVMV. Now this is equation 2. Divide both sides with MA, divide both sides with MA. So HMA divided by MA equal to HAMA divided by MA plus HVMV divided by MA. Now cancel this MA and MA. So remaining values are H is equal to HA plus HV divided by mass of the water vapor. So this is the enthalpy of the water vapor, this is the mass of the water vapor, this is MA is the mass of the dry air, So mass of the dry air, the ratio of the mass of the dry water vapor to mass of the water vapor to mass of the dry air is equal, that is 1 is equal to specific humidity, that 1 is equal to specific humidity or humidity ratio, that into. So MV equal to mass of water vapor, mass of water vapor. So MV divided by MA is equal to humidity ratio, Now this HA is equal to it is a specific, it is a enthalpy of the dry air. So enthalpy of the dry air, write in terms of Cp into T, write in terms of Cp into T per kg. So this is specific humidity or humidity ratio. Now this is HV is the enthalpy of water vapor. So enthalpy of the water vapor is equal to L plus latent heat plus, it is a sum of enthalpy of water vapor, it is a sum of latent heat and sensible heat. So the sensible heat to Cp, specific heat at constant pressure of the water vapor, and temperature and temperature and temperature. So now, so H is equal to Cp T. Similar again, written it is a L plus Cp T see here. So we, this is the, this is a specific enthalpy, this is specific heat at constant pressure of water vapor, sorry, dry air, specific heat at constant pressure, CPA, specific heat at constant pressure, pressure of dry air, of dry air, CPV, specific heat at constant pressure of water vapor, water vapor, water vapor, water vapor. So T is the dry bulb temperature, dry bulb temperature, dry bulb temperature, dry bulb temperature. See here. So H is equal to specific enthalpy, specific enthalpy in terms of kilojoule per kg of dry air, see here. So the H is equal to Cp, the Cp value of the, for specific heat at constant pressure, the value in value is equal to 1.005, 1.005. So the specific heat at constant pressure for the water is equal to 1.88. Next to the dry bulb temperature in degree centigrade, the specific heat value, specific enthalpy value. Next, this is the latent heat, this value is 2500 kilojoules, kilojoule per kg. So now substitute all these values in this equation. So the enthalpy, then the enthalpy of the moist air is equal to, so enthalpy of the moist air, CPA, the CPA is equal to 1.005, 1.005. So this is the table temperature. So this is the specific humidity. Next, 2500 plus CPV, specific heat at constant pressure of the water vapor, 1.88 dry bulb temperature. So this is the equation to find the enthalpy of the moist air. This is the equation to find enthalpy of the moist air. It is in terms of kilojoule per kg. It is kg of dry air. Kg of dry air. Kilojoule per kg of dry air. Now we will discuss a small problem on enthalpy. So read this problem. So determine a partial pressure, relate, relative humidity, enthalpy of atmospheric air. Enthalpy of the atmospheric air when the dry bulb temperature is 35 degrees centigrade, wet bulb temperature is 23 degrees centigrade, and the barometer pressure is 760 mm of Hg. 760 mm of Hg. Determine the partial pressure. So what is partial pressure? And partial pressure of water vapor. Partial pressure of water vapor and relative humidity, that is pi PV by PS. Partial pressure at a saturated condition. Pressure at saturated condition. So what we need to find next? Enthalpy. So enthalpy, specific enthalpy. So the enthalpy is equal to, we know already, enthalpy is equal to 1.005 T. This is the dry bulb temperature. This is the specific humidity or relative humidity. Sorry, specific humidity. So in this one unknown values, this is the unknown value. So unknown value, this is also unknown value. This is the specific humidity or relative humidity. So what is the formula for the specific humidity? Specific humidity is equal to 0.622 PV by P minus PV. Here the PV also unknown value. Is the P is the atmospheric pressure. P is the atmospheric pressure. So how to find this PV value? So we know already, we have one equation to find this one. To find this one, what is that? So PV is equal to the carrier equation. Carrier equation is equal to PSW minus P minus PSW, TD minus TW. Nominator is 2800 minus 1.3, 1.8 T plus 32. So this is the equation to find the partial pressure of water vapor. So in this one, what is the PSW? This is the saturated pressure of water vapor at wet bulb temperature. Sorry, such wet bulb temperature. So the wet bulb temperature at dry bulb temperature. Wet bulb temperature is see here the wet bulb temperature. What is the wet bulb temperature? Wet bulb temperature is equal to 23. At 23 corresponding, the pressure is equal to, the pressure value equal to from the steam table we get the corresponding to 23 degrees centigrade. The in terms of mm of Hg, 21.06 mm of Hg. P. This is the at atmospheric pressure. This is the atmospheric pressure given in terms of 76750 mm of Hg. 750 mm of Hg. 750 mm of Hg. What is the next unknown value in this equation? So unknown value is nothing here. So this is the atmospheric pressure. So now substitute 750 minus 21.06 dry bulb temperature. What is dry bulb temperature here? Here the dry bulb temperature is the 35 degrees centigrade. Wet bulb temperature is the 23 degrees centigrade. Here the 1.8. So dry bulb temperature is 35 degrees centigrade. Wet bulb temperature is 23 degrees centigrade. So 1.8 divided by 2800 minus 1.3 1.8. Dry bulb temperature is again how much? 35 plus 32. So from this equation we will get PV. So PV is equal to, from the calculation we can get the value 15.18 mmHg. So why it is in terms of mmHg? So we substitute this total pressure, atmospheric pressure and water vapor pressure in terms of mm of Hg. That's why the PV also in terms of mm of Hg. Now this is the PV value in terms of mmHg. What is the PS value? So the PS value that one is at dry bulb temperature of 35 degrees centigrade. So from steam table the PS value is equal to 42.4 42.2 mm of Hg. So the next, the relative humidity, that one is equal to PS by PV. Sorry, PV by saturated. The water pressure, partial pressure at normal condition to partial pressure at saturated condition. So the PV, the value 15.18 divided by 42.2. So into it is in terms of percentage. So that one is equal to 35.97 from the calculation, that is percentage of the relative humidity. Next, the enthalpy. So enthalpy, specific enthalpy. So that one is equal to, we know already. So that H is equal to 1.005. Just now we got the derivation. So that this is the relative humidity 2500 plus 1.88 the above equation. This is the unknown value, humidity ratio. So this humidity ratio is equal to uh, 0.622 PV divided by P minus PV, P minus PV, P minus PV. 0.622 PV value is equal to 15.18 divided by 750 mm of Hg minus 15.18. So from that we get the value. Is equal to 0.01285. That is value in terms of kg per kg of dry air. So now substitute this value in enthalpy. So enthalpy is equal to 1.005. The dry bulb temperature. What is dry bulb temperature? That one is equal to 35 degrees centigrade. So next is the value. This is the relative humidity ratio. That one is equal to 0.01285. Next value is 2500 plus 1.88. The dry bulb temperature, that is equal to 35 degrees centigrade. So finally from the calculation, finally we get the value of 68.145 kilojoule per kg of dry air. Small problem on air conditioning. The air supplied to a room of building in winter is to be at 17 degrees centigrade and have a percentage of relative humidity is 60%. If the barometric pressure is 1.01326 bar, calculate the humidity ratio. So the given data dry bulb temperature is 17 degrees centigrade, the relative humidity is 60%, and the barometric pressure is 1.01326 bar. Remaining is humidity ratio. To determine the humidity ratio, what is humidity ratio? Is a formula for the humidity ratio is equal to, it is denoted by omega. So the omega is equal to 0.622 PV P minus PV. Here P is the barometric pressure, PV is the vapor pressure. So the PV is the partial pressure of water vapor. Partial pressure of water vapor. So P is the barometric pressure. barometric pressure or moist air pressure, moist air pressure. So to determine the PV, how to determine this PV also unknown value. So from relative humidity, the pi equal to the vapor partial pressure of water vapor to partial pressure of saturated water vapor at saturated conditions. So this partial pressure, this partial pressure at saturated condition, that one is equal to, it is a corresponding to the pressure at a dry bulb temperature. This is the corresponding at pressure at a dry bulb temperature. It is collected from the, it will be collected from the steam tables. See here the corresponding, this is the saturation temperature, dry bulb temperature, saturation temperature. At this temperature, what is the temperature of dry bulb temperature? This is the 17 is the dry bulb temperature. So corresponding to this is the column of pressure column, this is the temperature column, this is the specific volume column. So corresponding to this 17 degrees centigrade, the value of pressure is 0.01936, 0.01936. This is corresponding to dry bulb temperature. So that is the value of PS is 0.01936. 0.01936. So here we substitute now according to this. So the pi is a 60%, so it means 0.6. The PV is the unknown value, the saturated vapor, that is equal to 0.01936. So from that the PV value is equal to PS 0.6 into 0.01936. That one equal to 0.011616 bar. Now what is the specific humidity ratio? What is the humidity ratio or specific humidity? What is the humidity ratio or specific humidity? The humidity ratio is equal to 0.622. So PV value is, what is PV value? PV value is equal to 0.0111616. The denominator is the P is the total pressure, 0.01326 minus 0.01326 minus next the PV value is 616. So from the calculation we get the final value is equal to 0.007213. It is the units is kg per kg of dry air, kg per, once again, kg 0.0072213 kg per kg of dry air, kg per kg of dry air. One more problem on air conditioning. In a laboratory test, a sling psychrometer recorded dry bulb temperature as 30 degrees centigrade and the wet bulb temperature as 25 degrees centigrade. Calculate partial pressure of water vapor and relative humidity, specific humidity, dew point temperature. Assume the atmospheric pressure is 1.0133 bar. Once again, in a laboratory test, a sling psychrometer recorded the dry bulb temperature. So given data, so the dry bulb temperature is how much? Recorded dry bulb temperature is 30 degrees centigrade. Or wet bulb temperature, given data, wet bulb temperature is 25 degrees centigrade. These are the next to atmospheric pressure, P atmospheric pressure or total pressure 1.0133 bar. So this is the given data. What we need to calculate: partial pressure of water vapor and relative humidity, specific humidity, dew point temperature. So what is formula for calculate the partial pressure of water vapor? According to the Clausius equation, the partial pressure of water vapor is equal to partial pressure of water vapor is equal to PV. PV equal to PSW minus P. This is PSW dry bulb temperature, wet bulb temperature 2800 minus 1.3 1.8 dry bulb temperature 32. So in this equation, this is the carrier equation to find the water partial pressure of water vapor. Here the values are PSW. This is the saturated pressure at wet bulb temperature. This value is saturated pressure at wet bulb temperature. This pressure. This is the total pressure of atmosphere or atmospheric pressure or total pressure. So this P equal to. So this equal to P. So this is PSW again. This is the saturated pressure at wet bulb temperature. So this is corresponding to this wet bulb temperature. From it we need to collect from steam tables. So this is the dry bulb temperature. Already we have that one, dry bulb temperature and wet bulb temperature. So this is the dry bulb temperature. This is the wet bulb temperature. So this is the dry bulb temperature. So from steam table we need to collect this. This is the saturated pressure corresponding to dry bulb temperature. PS, this is the corresponding to this saturated pressure, this is corresponding to dry bulb temperature. PSW, this is corresponding to wet bulb temperature. So when this value from steam tables, from textbook steam tables, we check the value from steam tables. Corresponding to pressure, corresponding to temperatures, properties of see here. So this is the properties of dry saturated steam with temperature and parameters. So this is the saturated temperature line. So this is the column pressure line. So from what is the wet bulb temperature? Wet bulb temperature is how much? 25 degrees centigrade. 25. So here 24 we have only 24 and 26. 24 and 26, 24 and 26. 24 values 0.29, 0.02982. 26 is 26. 26 values 0.03360. So 24 values, this one 26 value double 3. We need to take in between these two values. In between these two values. So the difference is 2. So that value is equal to PSW, that value 25 is equal to 0.03166 bar. Next at wet bulb temperature, dry bulb temperature, the pressure is equal to, see here, this is the 30 degree centigrade, corresponding to this one 0.04242, 0.04242, 0.04242 bar, 42 bar. Now substitute these values in this equation, so this is PV. PSW, what is the value of PSW? 0.03166 minus P. What is the value of P? 1.0133 minus PSW values 0.03166 and TD, the dry bulb temperature is 30 degrees is 25 degrees centigrade, so 2800 minus 1.3, 1.8. So dry bulb temperature is 30 degrees centigrade plus 32. So from the calculation, finally we will get the value 0.0284 bar. This is the partial pressure of water vapor. This is the partial pressure of water vapor, 0.0284, 0.0284 partial pressure of water vapor. PV is equal to 0.0284 bar, 0.0284. dew point temperature. Dew point temperature TdV notation. The temperature, this is the temperature corresponding to partial pressure of water vapor. Partial pressure of water vapor, that is the PV, is equal to partial water vapor 0.0284, 0.0828, corresponding to this pressure. The temperature is equal to dew point temperature. So the partial pressure of water vapor 0.0284 from steam tables. The pressure, this is the saturated temperature, this is the partial pressure column. So see the 0.028. So see here, and this is 0.02642, this is 0.02982. so in between the corresponding 0.026 to corresponding temperature is 22, 0.02982 corresponding pressure is 24. In between, the value is in between. See this, the value is in between these. The partial pressure is 0.0284 here, 2629. So in between this value. So the value is this, corresponding to this value is 23 and 22 and 24. So in between value is 23 centigrade. So the temperature corresponding to partial pressure water vapor, partial pressure of water vapor is 23. So the dew point temperature is dew point temperature is 23 degrees centigrade.